we are done discussing the circle, the ellipse, and the parabola, in this video we will be discussing on the last conic section, which is the hyperbola. So first, let us define the hyperbola.
A hyperbola is the set of all points x, y in a plane in which the difference of whose distances from two fixed points called the foci is constant.
What are the different parts of the hyperbola?
Let us study the different parts of a hyperbola. This is an example of a hyperbola with a horizontal transverse axis. So we have our center here at the origin. We have two vertices, the vertex 1 and the vertex 2. We also have two foci, the focus 1 and the focus 2. We have our co-vertex here and here. These are also the endpoints of our conjugate axis. So this is our conjugate axis and this is our transverse axis. Now we have two intersecting lines. These two lines are called the asymptote of a hyperbola. So this is where the hyperbola approaches with large numbers of x and y. But take note that they never touch each other. Now we also have our central box in blue color. Take note, in a hyperbola, the center, the vertices, and the foci are always on the transverse axis. And A is the distance from the center to our vertex. B is the distance from our center to the endpoints of the conjugate axis or to our co-vertex. And C is the distance from the center to our focus. And the formula for finding the C value in a hyperbola is C squared is equal to A squared plus B squared, unlike in an ellipse that we have C squared is equal to A squared minus B squared. So these are the different parts of a hyperbola.
Now let's talk about the standard equations of the hyperbola. So as you can see here, we have four equations of a hyperbola. These first two equations are the equations of a hyperbola if its transverse axis is horizontal. On the other hand, these two equations are the equations of a hyperbola if its transverse axis is vertical. So let's take a look at the first two equations. These are the equations of a hyperbola if its transverse axis is horizontal. So first we have x squared over a squared minus y squared over b squared is equal to 1 if the center is at the origin or at 0, 0. On the other hand, if the center of a hyperbola is not in the origin anymore and its transverse axis is still horizontal, the equation is this one. So quantity of x minus h squared over a squared minus quantity of y minus k squared over b squared is equal to 1. So again, that is if the center is at hk or not at the origin. Okay, letter B. If the transverse axis of a hyperbola is vertical, so it goes along with the y-axis. Now first, if the center is at the origin or at 0, 0, the equation would be y squared over a squared minus x squared over b squared is equal to 1. But if the center is not in the origin anymore, so it has values hk, the equation is quantity y minus k squared over a squared minus quantity x minus h squared over b squared is equal to 1. So these are the four standard equations of a hyperbola depending on the center and on the position of its transverse axis. Now, let us examine these four equations. How do we identify if the transverse axis of the given equation of a hyperbola is vertical or horizontal? In these first two equations, we can observe that the first variable here is x. But on these equations, the first variable here is y. So we can say that the transverse axis of a hyperbola is horizontal if the first variable here is x and it follows that the denominator is a squared. So we have x over a and our y is negative. So that is the transverse axis is horizontal. However, if the transverse axis is vertical, we have here the first variable is y and its denominator is a. So our x variable here is negative. So the transverse axis is vertical. Now always remember that the equation of a hyperbola is also always equated to 1. And we have here subtraction sign because it talks about the difference of two distances by its definition. So difference. But in the ellipse, it is positive here. In hyperbola, it is negative. But both of them are equated to 1. Now let us study how to sketch a hyperbola. We have here an equation, x squared over 16 minus y squared over 9 is equal to 1. So first step is we will identify the center and the position of this hyperbola. So since we don't have the h and a values here, we can conclude that the center of this hyperbola is at the origin. So it has coordinates of 0, 0. How about the position of this parabola? So since we have here the first variable is x and it is positive and our y is negative, therefore the transverse axis of this hyperbola is horizontal. Again, the transverse axis is horizontal because our x is positive and our y is negative. Next is we will identify the a, b, and c values for this hyperbola. Now, in our equation of a hyperbola, a squared is always the denominator of the positive variable. So whichever is the positive, the denominator of that is a squared. Now, here our positive variable is x. Therefore, this is the a squared and this is the b squared. So our a squared is 16. Since this is a squared and we are looking for a, so we will get the square root of both sides. So we have our a is positive 4. So if this is a, our b squared is positive 9. So b squared is positive 9. Get the square root. So the answer is positive 3. So our a is 4 and our b is positive 3. Now, in order for us to get the value of c, we will use the formula c is equal to a squared plus b squared. So we have here the formula c is equal to square root of a squared plus b squared. Now, if you are wondering, the formula in finding the c of an ellipse is c is equal to a squared minus b squared. Now, if you are confused because they don't have the same formula in finding the c value, in ellipse we have minus and in hyperbola we have plus. Now, please remember that in an ellipse, the distance from the vertex 1 to vertex 2 is much greater than the distance from the focus 1 and the focus 2. So this is the value of a and this is the value of c. So that's why we have a squared minus a squared because vertex is greater than the focus. However, in the hyperbola, the distance from vertex 1 to vertex 2 is much smaller than the distance from focus 1 and focus 2. So here in hyperbola, our focus is greater than the vertex or longer than the vertex. So that is c is greater than a. Therefore, we have here the formula a squared plus b squared. So now let's solve for the c value of this hyperbola. So we have to substitute. Our a squared is 16 and our b squared is positive 9. So 16 plus 9 we have 25. And square root of 25 is positive 5. Therefore, our c is positive 5. So our a, let's assign this one. This is for our vertex. B is for the endpoints of the conjugate axis. So this is conjugate axis and C is still for our focus. So now let's sketch the graph of this hyperbola. So first step is we will draw a Cartesian plane. x-axis and the y-axis. First step in sketching a hyperbola is we will first sketch the central box using the value of A and the value of B. So central box, since the transverse axis of this hyperbola is horizontal, we can expect that our A is in the x-axis and our B is in the y-axis. So first, let us count 4 units to the left and to the right because our A is 4. So 1, 2, 3, 4. 1, 2, 3, 4. This is another A. 1, 2, 3. This is B. 1, 2, 3. This is B. So we can sketch our central box. Okay, so this is our central box. Next step is sketch the asymptotes. Now, asymptotes are the two intersecting lines in which the hyperbola approaches, but they will never meet. So, our asymptote, let's start from this edge of the central box. These are our asymptotes. Next is we will plot the vertices and the focus. So since A is for vertex and we have here A, therefore we can have it as vertex 1 and the other A is for vertex 2. Now A is for vertex and C is for the focus. Since our C is equal to 5, we can just have to add 1 to our A because this is 4. So 4, this is 5 units. So this is our focus 1. The other hand, this is 4 units. To get 5, we will add 1 for our focus. So this is focus 2. So let's count 1, 2, 3, 4, 5. So this is 5 units because C is equal to 5. So next, we will sketch our hyperbola. So we will start from the vertex. Let's sketch a branch of the hyperbola approaching the asymptote, but always remember that they will never meet. Asymptote, another branch from the vertex again, and this one. So this is our hyperbola. And we can get the coordinates of our vertices and our foci. So vertex 1 and our focus 2. Okay, since our center, our vertices, and our foci are just aligned in 0, therefore they have the same y, but they have different x coordinates. So they are just aligned. So our y is 0 for all of the points. So we can write 0, 0, 0, and 0. So we just have to find for the x coordinates of these 4 points. So vertex 1 we have here 1, 2, 3, 4, and this is negative because it is in the left. So negative 4. So this is negative 5 because this is negative 4. So negative 5. And for our vertex 2 we have positive 1, 2, 3, 4. So this is 4 and this is positive 5. 1, 2, 3, 4, 5. So these are the coordinates of our vertices and our foci. Next and last, we will label our graph. So x squared over 16 minus y squared over 9 is equal to positive 1. So this is how to sketch a hyperbola with the center at the origin. Next example, we have quantity of y plus 3 squared over 64 minus quantity of x plus 1 squared over 36 is equal to positive 1. So first, we will identify the center and the position of this hyperbola. So center, we have here our h, negative 1. We have here positive 3. So that is negative 3. So our center is at negative 1 and negative 3. Next is the position. So here, our positive variable is y, and we have negative x. Therefore, we can conclude that the transverse axis of this hyperbola is vertical. Next is we will solve for the values of a, b, and c. So our a squared is equal to 64. Again, a squared is always the denominator of the positive variable. So our positive variable here is y because x is negative. So therefore, it is our a squared. So a squared is equal to 64, therefore our a is equal to positive 8. Next, our b squared is 36. So b squared is equal to 36. Our b is positive 6. Next, solving for c, we have the formula a squared plus b squared. Again, this is plus here. So our a squared is 64 and our b squared is 36. So 64 plus 36, the answer is positive 100. And square root of 100 is equal to positive 10. Therefore, our c is 10. So again, our a is for the vertex, our b is for the endpoints of the conjugate axis, and our c is for the focus. This is our Cartesian plane, this is our x-axis, and this is our y-axis. So first step is we will sketch the central box using the values of a and b. Now, where should we put our a value and our b value, because the transverse axis of this hyperbola is vertical. Now, in the transverse axis, we have here the a, the c, and the center. Therefore, if the transverse axis of this hyperbola is vertical, we can expect that our vertex and our focus is in the y-axis or the vertical axis. So first, let's plot our center. In the first example, we just automatically locate our a and b because our center is at the origin. But here in example 2, our center is not in the origin anymore. So first step is to plot -1 and -3. So -1 is here and -3, 1, 2, 3. So here is our center at the third quadrant with coordinates of -1 and -3. So now let's have our central box. So our a is positive 8. So we will count 8 units upward and downward again because the transverse axis is vertical. So 1, 2, 3, 4, 5, 6, 7, and 8. So this is our 8 here. Next, 1, 2, 3, 4, 5, 6, 7, 8. This is another a. And for our b, we have 6. This is for the endpoints of the conjugate axis. So 1, 2, 3, 4, 5, 6. This is our b here. And to the left, 1, 2, 3, 4, 5, 6. And this is another b. So we have our a, b, b. So let's sketch our central box. Okay, so this is our central box. Next step is we will sketch the asymptote of this hyperbola by just connecting the four edges of this central box. So let's start from here. So this is our asymptote. Next is we will plot our vertex and our foci. Our vertex is 8 units from the center. So this is 8. So this is our vertex 1. And other 8 is for the vertex 2. Now our C is 10. So for our focus, 10, because this is 8 already, we will just add 2 for our focus. So 8, 9, and 10. So this is our focus 1. And for our focus 2, this is already 8 units from the center. We will just add 2 units. So 8, 9, 10. So this is for our focus 2. So we already have our foci and our vertices. And this is our center. So now let's sketch already the graph of the hyperbola. So from the vertex, since this is our vertex and our transverse axis is vertical, so our hyperbola is like this. this one, and so this is our hyperbola. So let's find the coordinates of our vertices and our foci. So vertex 1. Okay, since our foci, vertices, and center are just aligned in the x, which is -1, we can say that the x coordinates of these 4 points is also -1. Again, because they are just aligned in x, which is -1. So we will write -1, -1, -1, and -1. And for our vertex 1, we have here 1, 2, 3, 4, 5. So this is +5. For our focus 1, 1, 2, 3, 4, 5, 6, 7. So this is +7. Our vertex 2, this is -3 here, -1, -2, -3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have -11. And for our focus 2, because this is just 2 units from our vertex 2, so we will just add 2. This is -13. So let's check. -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is correct. And lastly, we will label it y plus q.
So here ends our lesson on hyperbola. I hope that you understand. Again, this is your teacher, Miss Lorian Cabanisa. Keep safe, everyone, and